Hello, and welcome back to my Kubernetes series. In the last video, we set up the certificate manager and tested its functionality. In this video, we will set up a webhook in order to obtain a valid certificate for a dynamic DNS service. So without further ado, let's take a look at those dynamic DNS webhooks. As I mentioned in my introduction video, I will be using a duckdns domain name. This dynamic DNS service does not allow me to create an A record, which would make a standard certificate request through our deployed certificate manager fail. For these situations, some very smart people created webhooks that help you to obtain a certificate for these dynamic domains. The one for duckdns can be found on GitHub. Others, for example for Linode, can be found on GitHub as well. I found additional ones, for example for DigitalOcean. The documentation is right on the cert-manager page. Additional ones such as FreeDNS, NoIP or Cloud DNS I found as well. I will leave those links in the description below if you use one of those dynamic DNS resolvers. You will have to walk through the setup and the configuration of these resolvers yourself, as I am not using these services. So I want to go back to the duckdns documentation and review the setup steps. As we scroll down and take a closer look at the documentation, we see that the cert-manager needs to be used in a version 1.2. That created my first challenge. As I want to follow the instructions as closely as possible, version 1.2 does not even start up in my cluster, as we are using a Kubernetes version 1.28. That is where my first challenge comes in. Version 1.2 of the cert-manager used settings and options in Kubernetes that were in beta at the time the chart was created. While Kubernetes and its options evolved, so did the chart for the cert-manager. So it is out of the question that we can use cert-manager in a version 1.2, and in my tests earlier I already successfully used cert-manager in a version 1.10 with the duckdns webhook. So in this video series I will go a step further and try to use the latest cert-manager in version 1.13.1 with the duckdns webhook. As we have installed this version in our cluster already, there is one change we have to make. In order for a DNS01 request to be resolved properly, we need to add something to the configuration of our cert-manager. This detail is the part in the documentation containing extra arcs. To make these changes to our existing deployments, let's switch over to the terminals. The deployment we want to update is called cert-manager, highlighted on your screen right now. To edit this deployment, enter kubectl edit deploy cert-manager -n cert-manager. This command will bring up the Vim text editor with the deployment in an edit mode. We have to scroll all the way down to the section spec template spec containers, under which we find the arcs entry. In here we need to add a dash followed by the copied command, but we have to take out the backslash here, as this slash is only necessary if you enter this command on the command line. Once that is done, we can exit the edit mode and write and quit. Once back to the command line, we see that a new replica set is showing up. As we edited the deployment, this replica set allows us to switch from one version of a deployment to another. Kubernetes scales this new version of the cert-manager up, while, as soon as this pod is running, removing the old, unedited deployment. This process is called rolling updates, where one deployment is scaled back while a new one is scaled up. If something would go wrong during this upgrade, no disruption of service occurs, as the older pods that are to be decommissioned are only taken down if the new ones start up properly. As our pod started up without any problems, let's move on to the next step, which is the deployment of the webhook. Unfortunately, that is where I ran into massive problems. The Helm chart that is mentioned in the documentation does not exist anymore. So there is no way we can install this webhook the easy way. However, I found an instruction which Javier Marasco, I hope I pronounced your name right, described how to download the GitHub repo for the webhook and install the same through Helm. If we scroll down in his instructions to step 11, he describes how the webhook works. Please feel free to give his instructions a read. I left the link in the video description. My next step is detailed in his section 12. I will start by downloading the GitHub repo from Ebrian into the folder that we created. So let's switch back to the terminal, enter that folder, and download the GitHub repo. Yes, we do have a folder for our webhook already, so we go into cd02. That folder is empty. Great. Now we copy and paste the clone command from Javier's website and paste it in here. That does download the GitHub repo. Let's take a look. It's in here, and now we go into that folder. Within this repo and this folder structure, I am looking for the values.yaml. I want to use this file to configure the webhook, as I don't like long commands on the console. The main reason for that is that it is more difficult documenting these commands instead of going back to a file in which you can see and find the values you used for a deployment. So let's try to find, as I already looked it up, I know where to look for the file. So deploy, then cert-manager webhook, and in here we have the values.yaml. So let's copy this file, values.yaml, to duckdns webhook values.yaml. If I exit these folders again, nope. And here is my YAML file. As the file is copied, let's do vim duckdns webhook values YAML. At first, I want to change the group name, and I want to replace that with my duckdns domain. The second change, and probably the most important one, is we need to align the service account name that we gave our cert-manager with the service account name in this webhook. And we used, and I will show that on the screen right above me here, cert-mgr controller manager. This is the service account name we used during the setup of cert-manager, and that is the same service account we need to use for our duckdns webhook right here. The next entry we want to change is the duckdns token. To find that token, let's quickly switch over to the duckdns website and find the detail we're looking for. duckdns. Log in with your account. and the start page should greet you with everything you need to know. Copy the token and switch back to our terminals. As we are back in the terminal, enter the edit mode and paste the token. Let's move further down in the file to the cluster issuer. Change your email address and use an email address which is real, as Let's Encrypt will send you emails about issues with your certificate, for example, if it's running out and that you need to renew it, or anything else that might have to do with the certificate that's being issued to you. So use an email address that you check on a regular basis. I'm going to add my email address in here. And we'll remove the rest. The next entry we want to change, we want to create a staging cluster issuer. So we replace the false with true and remove the false. And we want to do the same with the production issuer as well. So let's change that to true, and that was the last change we're going to do in this file. So let's write and quit, and are back at our console. As we have defined and updated everything we need, let's now deploy this webhook. The command, as we have no Helm repository, is slightly differently than for previous deployments. We can install the Helm chart, however, with the command helm install cert-manager webhook duckdns -n cert-manager. We provide our values file with -f duckdns -webhook values.yaml, and we reference the chart with /deploy cert-manager webhook duckdns. This last piece will look into the directory and discover a file called chart.yaml and deploy our webhook with all its dependencies. As we hit enter, we can watch this hook start up in the cert-manager namespace. As the webhook is fully started up, we have to test this deployment. At first, let us check that the cluster issuers are both created. We do that with kubectl get cluster issuers and hit enter. We can find the cert-manager duckdns production and staging. Both are true when it comes to the ready status. To test if this deployment works, we will be using the staging cluster issuer. Javier has a great description on why you should use staging first. Let's just say if you ever want to be able to obtain a valid certificate for an application you plan to deploy, you probably should test first if your webhooks work or if you have to identify potential issues. The beauty of using the staging issuer is that as soon as you fully understand how the certificate process works, you just have to change one value and you are good for a permanent certificate which will be accepted by all browsers. To create a testing certificate, let's head over to the previous deployment we used to test the certificate manager in the first part of this video. We do that with changing back into our one folder, and in here we still have the ingress resource which we're now going to customize to use our cluster staging issuer. Vim ingress. The first change we want to make is to call the right cluster issuer, which in this case is cert-manager webhook duckdns staging. The next modification I want to make is I want to add the ingress class. So I want to make sure that whatever traffic comes in, it uses the ingress class engines or engine X. With that done, as we are requesting a certificate for a domain that we have through duckdns, we cannot use testingcert.com because we don't own this domain. As that is the case, we must change this domain to our duckdns domain. So let's do that. Once done, we should also change the host down here. And we are ready to write and quit the file. Unfortunately, the change that we just executed under the hosts entry also means that we have to go back to our browser and change the redirection of sites in our network. So if we switch back to our browser and go to our Pi-hole, local DNS, DNS records, we need to modify the duckdns web service. We do that by entering the domain that we just updated in our ingress file. And we reroute that traffic to the specific IP address. Once added, we can go back to our terminals. Before we deploy the ingress resource, however, I want to expand the terminal to full screen to follow along what happens during the issuing of a cluster certificate. As I set up my terminal to fill the entire screen, let's now deploy the ingress resource kubectl apply-f ingress.yaml, and we're going to copy and paste another command to watch what happens during the issuing of a cluster certificate. Alright, it looks like I was a little too slow to watch. Anyway, we can see that there was a certificate request from the cert-manager, and which was approved, and a certificate was created, rather a secret was created. That secret is visible right here, and it contains a TLS, or it's of category TLS. So let's get out of here and kubectl get secret -n test web. We're going to describe said secret TLS secret. We can see for which domain it was issued. We can see that it was issued for our staging cert-manager webhook, and it contains a TLS certificate and a key. If we switch back to our browser and take another look at our domain, we should be able to reach the web server that we set up in our Kubernetes cluster. Once we open up the website for which we just set up our ingress resource, we will get a not private warning. In this case, we want to accept that, and we're happy with it because what this tells us, first of all, we have a certificate which is indicated by the certificate authority is invalid, and if we take a closer look at the certificate, it is set up for our domain we specified. It is set up through a staging service. It is issued by Let's Encrypt, which is what we wanted, and it has an issued on date as well as an expiry date. It shows a certificate and a public key. What this tells us is we were successful and can now just switch over to the production version of that cluster issuer and issue a valid certificate for a website. I will switch back to the terminal and we will have a look how to switch from a staging to a production issuer with vim ingress YAML. All we have to do is switch from a staging to production. If you execute this ingress resource, you will get a valid certificate issued for your duckdns dynamic domain, and your website will be trusted. You still have to make sure to submit your external IP address to duckdns, so in case your ISP decides to change your address, you still have access to your services. I will walk through a small deployment for Kubernetes in the next video, as well as the certificate replicator, as I will use that certificate in several different deployments. In summary, what's working? We have a cluster with a load balancer and ingress controller. We just deployed a certificate manager and a webhook for a dynamic domain for which we can request certificates which will be trusted by all browsers. What's left to do? What's next? We have two smallish items left in our setup to do. Next, I will talk through a small deployment which will submit your external IP address, which you obtain through your internet service provider, to duckdns, so access to your services is uninterrupted. I will also deploy a certificate replicator so I can use this certificate with different other services and websites. Thank you so much for watching. I will see you in the next video.